Hello everyone, we are back again now with part 16 of the chapter Light, Reflection and Refraction, and today we'll be starting with the new concept, and the concept is spherical lenses. So when we talk about spherical lenses, before we actually go ahead with the lenses, we need to understand why do we call them as spherical lenses, because they are part of a sphere. Now the difference when we talk about spherical lenses and spherical mirrors is that spherical mirrors are made out of one sphere, whereas lenses, when we talk about spherical lenses, they are made out of two spheres. So you can see, if I'm talking about this is a convex lens which is made out of one sphere, and similarly on the other end another sphere. Similarly, when we go to the concave lens, you can observe here that this is one sphere and this is forming the other sphere. So basically, when we are talking about a spherical lenses, the lenses are made out of transparent material. Now this is very important. Why are we saying transparent material? Because lenses allows light to pass through, whereas when we talk about mirrors, they were opaque. So a spherical lens is a transparent material bounded by two surfaces, one or both of which are spherical. Now it's not necessary that both these surfaces should be spherical, but in our concept discussion of convex and concave lenses, we'll be discussing about the spherical lenses part of two spheres. So when we start with the discussion, spherical lenses are mainly of two types, which are convex and concave, and you can see that diagram here. Convex lens is bulging outward and concave lenses bulging inward. Many a time it happens that students are confused about which is which lens. So if you observe, the lens which looks like a tree trunk is concave lens. So you can see this became a tree, and this is how students can be able, student can recollect how to remember what exactly is concave lens. So concave lens which exactly looks like a tree trunk. So basically, convex lenses are thicker in the center and thinner at the edges. You can see thicker in the center and thinner at the edges. Similarly, when we talk about concave lens, they are thinner in the center and thicker at the edges. Now, when we was talking about spherical mirrors, we spoke about some basic terms. Similarly, we have several terms which are very basic and which we should know. So first term is this. So you can see in the center of the lens, we have a point. For mirror, it was optical. For mirror, it was pole. But for lenses, we have a center called as optical center. We label it as O. In some books, you will also find written it as C, one and the same thing. Next important point to remember is the line. The line passing through optical center is called as principal axis. This is the line which is passing through optical center. Now, if we observe, when the light rays passes parallelly through convex and concave lens, you can see I am passing light parallelly. So it is observed that via passing through convex lens, light rays are meeting at a single point, whereas when we talk about concave lens, light rays, when they pass, they meet basically at a point behind the mirror, behind the lens. I'm so sorry. So you can see in this case here, the light rays are not actually meeting, they are diverging away. And that's why we say that the convex lens is converging lens and concave lens is diverging lens. So if you hear the term concave and convex, and if you don't get which is converging, which is diverging, this is the diagram. You can see light rays are coming parallel here, and after refraction, now this time it's not reflection, it is refraction, because transparent medium, they meet at a single point, and that's why they are called as converging rays, because they're passing through convex lens and the lens is converging lens. The point at which they meet is called as focus. In this case, focus is here behind I could say on the same side where the object will be kept. So in this case, image formed would be real. I'll say focus is real, and here the focus is virtual. We'll also have a look at some more terms. Let's have a look at it. So you can see the as and point of center, it could be labeled O, it could be labeled as the line passing through optical center perpendicular, you can see this is the face of the lens, and these are all the rays, and this is principal axis which is perpendicular to the face. Going ahead with the next term, when we are looking at it, we'll go for individually, for first for convex lens and then we'll go for concave lens. So principal focus, the point at which light rays are converging after refraction. Convex lens is a point on the principal axis to which light rays parallel to principal axis converges. Converges means they come and meet. This is the meaning of converge. Light rays are meeting at a single point. Now, lens has two foci, which means two focuses on both the ends. Because it's a transparent medium, we can keep the object on this side also. And if we want, we can keep the object on this side also. If we keep the object here, we will consider the focus of the right side. If we keep the object on the left side, then we will consider the focus of on the left side. But as per sign convention, we keep the object always on the left side of the lens or the mirror when we talk about. The focal length of a lens is the distance between optical center and principal focus. So for mirror, it was pole and focus. For lenses, it is optical center and focus. That distance is called as focal length. A convex lens, as already discussed, is termed as converging lens because light rays parallel to the principal axis, they converge or they meet at a single point. And convex lens has a real focus because light rays are actually crossing each other. You can see here, you can see light rays are actually crossing here like this. You can see this scenario, light rays are crossing and the rays are not dotted, which means the focus of the convex lenses are real. Going ahead for the concave lens. So when we talk about concave lens, the principal focus of concave lens is a point on its principal axis from which light rays originally parallel to the axis appear to diverge. So you can see the word is coming as appear, which means it's not real. So we can come up to this point directly that concave lens has a virtual focus. The rays are, if you stand here, you feel the light rays are coming from focus, but they are not. They are actually parallel and they are getting diverged. That's why we call the concave lens as diverging. So when we basically summarize differences between concave and convex lens is diverging, convex lens is converging, concave lens has virtual focus, convex lens has real focus. These were the point of differences between convex and concave lens. In the next video, we'll talk about rules for formation of images by convex lens. So stay tuned and I hope you are learning something. That's it from my end. Thank you and have a great time. Bye-bye.